So today we're going to take our first baby steps and we're going to attend AI preschool. So let's dive right into it. First of all, let's dive into our first lesson. Our first lesson is that AI is effectively a learning machine. It learns based off of mathematical algorithms. It processes based off of a number of parameters, parameters being like neurons in its brain, and it learns directly from data. These three things combined are essentially the major elements of machine learning, which makes up AI overall. And then so within this, machine learning is the basis of AI. It's like the building block of AI. How AI learns is machine learning essentially. And then so this is essentially a breakdown of that machine learning process. So when we dive further into that learning process and we break it further apart, machine learning is essentially there's two end results we can say that the model can have, either regression or classification. And then regression meaning like predictions or periods over time, making predictions overall. Classifications meaning like is it raining or is it not? Is it category A, category B? And then what you see here as well is that under regression, we've got linear regression, random forest, multi-layer perceptrons. And then under classifications, we've got like logistic regression, dependency variables, decision trees, KNN, etc. And then these are all different algorithms that fall under these two different, two big broad categories. So within these big broad categories of learning, of paths of regression and classification, you can have different algorithms or different kind of like the makeup of them, right? The individual kind of layers of that. And then so within these two paths, there's essentially three different ways that the model can learn along these three paths. So hopefully you can see that there's this kind of a progression. And then so within these three learning paths, the most basic one is supervised learning, which is where you give the model data and you clearly label what the data is. This is a picture of a cat. Here's exactly what a cat is. Here's a description of a cat, etc. Unsupervised learning is where you give it the data, but you don't label it. Here's a cat, tell me what it is. And then reinforcement learning is where it's interacting with the cat. So it's not actually data. Like in a video game, it could run into a cat in a simulated environment. Typically, reinforcement learning takes place in simulated environments. And this brings us to generative AI. And then it's important to note that generative AI overall is a general subcategory of AI. And then I want to distinguish, let's take text out of this generative AI equation. So let's like natural language processing and LLM models, we're going to take them out for a second, right? And then let's say that generative AI is images, audio, video, these types of things, and these elements. These types of elements are different overall than any other type of AI that you would deal with. And then there's a few things to note within these. And then probably the most significant, important thing for you to note as a baby within this, as we go through this, is that when it comes to audio, images, and video, like a majority of the time, they're utilizing a process called reverse diffusion. And then I am hesitant to group reverse diffusion into like the overall category of like a broader category of AI and machine learning, because it's more it's not exactly in the same category as other things. So reverse diffusion is essentially just like denoising, right? You're solving the diffusion equation, and then by solving that diffusion equation, it just so happens that everything is made up of data. Images are made up of data, video is made up of data, audio is made up of data. It's made up of data and noise. And then by tracking and understanding that noise, and by noising and denoising, and then understanding the noise that certain images or audio or video makes, you can reapproximate, it turns out, the images, the video, and the audio. And then so to me, it's just a different process overall. And it's not true AI. And then so like I think that throws a lot of people off when it comes to this particular debate and this particular discussion, is because it's so unique and it's so in its own category, right? And then so that does bring us to LLM models and neural networks, which is what most people think of. So I think most people think of the one of these two, right? So they think of either what would be classified as typically a diffusion type of model, and then or they think of like an LLM model. And then so they're two very different things, right? So up front, we've gone over how diffusion works, which is again images, video, audio, etc. Not and so text generation, natural language processing, LLMs, etc. falls kind of under this neural network process, and then within this, natural language processing adds another layer onto this to translate essentially these matrices into actual like words, what are called tokens, and we can dive deeper into those in other courses. But within this, taking our baby steps, going through kindergarten, understanding this generalized process, what we need to understand overall with regards towards how LLM models and neural networks work is that they're based off of matrices and matrices. And matrices and matrices are exactly what we're looking at here, right? So on the left-hand side, we've got a column matrix, and then which we go up to a rectangular matrix, and then we can have a row matrix, which can go up into a square matrix, and then all of these can combine into identity and zero matrices. And then from there, we can combine like layers of zero matrices. So we can have multiple zero matrices, which if we combine multiple zero matrices, we can get into a square matrix. And then if we subdivide a square matrix, then we get into triangular matrices or diagonal matrices, which then get us into deeper layers, and we can go from there, right? But all of these are the building blocks of them are layers or matrices. And then this is all important because these matrices and all of this is essentially how the model learns. It translates information into these matrices flat out. It's like, and there's no other way to describe that process overall as to what exactly is occurring. And then so just describing that for you overall, it's this important. This is the most important concept with regards towards matrices, because then it translates into weights, and then so like weights could be, let's say that you have the word king, and then so the word king would have weights within a matrix, and then it could be 1, 2, 6 equals king in this particular matrix, right? And then so with regards towards the LLM models, they're crunching these numbers, and their brains are essentially moving these, like think of like their brains operating like Rubik's cubes of these matrices, right? That's kind of how I think about it in my head. And then these Rubik's cubes of matrices are shifting and generating numbers, and then they're going through their processes and forward and backward propagation, and they're flipping this way, flipping this way, flipping this way, flipping this way, etc. And then that's what is getting you your output and your result. And then that's also why I can't explain to you exactly how exactly it gets to the end result, right? I can tell you that like the process is like a Rubik's cube where it's flipping back and forth, but I can't tell you every single time, and no one can, what exactly it went twice to the right, 3 times to the left, 1 up, 2 down, etc. Like no one can. There's no way to determine that exact process, right? And that's the exact process that gets into when you start diving into these things. So with this concludes essentially preschool and taking our first baby steps, and this concludes overall essentially learning AI from the perspective of a baby. And then I hope that you've enjoyed this lecture and enjoyed this course overall. My goal has been to provide and give you this information in a different fashion than I've seen it presented overall before. And as the major criticisms that I see with people is that the AI courses that they see with regards towards people that have no knowledge with regards towards AI, they're too long and they're too in-depth. They're like too technical. So I try to avoid both of those things, and hopefully this course has served you well. And I look forward to seeing you in future lectures and more in-depth courses. So thank you very much.